Hey guys, this is the Vincent Code, and in this video we will talk about linked list delete and search operation. So this program is a continuation from the previous program that we created in our previous video. So if you haven't watched my previous videos, I will put the link on the description below. So let's start. So first is create a function for the delete position and search data. So we will just add the function on our previous code. Then in the main function, so we add the delete node and search data in the options, and then also in the switch case. So now without further ado, let's look at the code for our delete node. Is the code for our function delete. So first is to declare two integers. So we have I and pos. So I is for the loop and pos is for the position the user wants to delete, so the position of the node. So and then we have here two pointers. So we have temp and ptr. So the first thing that we will do is to check if we have a list or not. So we will check if start is equal to null. So if start is equal to null, that means we have no existing list, so we simply print the list is empty and then exit the program. Else, so if start is not equal to null, so that means that we have an existing list. So we will then ask the user to enter the position he or she wants to delete, so the position of the node, and then we will store it to pos. And then if pos is equal to 0, so by the way, we in this function we will start counting from 0. So the first node is in position 0, the second node is in position 1, and so on. So if position is equal to 0, if the user entered 0, so we just simply execute this code here. So ptr equals start, so we will store the value of start to ptr, and then here start equals start next. So start next is the address of our second node. So since we will delete our first node, so our second node now will become the first node. So that's why here start next start equals start next. So the value of our so the address of our next node now is stored in start. So that means that our second node is now the first node, and then here we display the value, so just for the confirmation for the user that the value has been deleted. So here we print the deleted element. The deleted element is %d, and then we call the ptr data. So ptr is the value of start, so here ptr data, so that means that the value that we will be printed here is the data of our start. And then to delete the node, so we execute this code free ptr. So ptr is the value of start, so that's it. So free ptr, so that means that we ask the computer to free that memory that the ptr have. So for example, if our start has memory, let's say 1000, so the computer will free that memory 1000. So the memory 1000 now is free or released by our computer. So else, if the position of the user entered is not equal to 0, so we will just go to this code. So this code will be executed. So before we explain this code, let's look at this representation on what happens when you delete a node. So for example, we have here a list. So we have here 4 values. So we have here position 0, position 1, position 2, position 3. So let's say that our node 1, so this is node 1, node 2, node 3, node 4. So if node 1 has a value of 1, node 2 has a value of 2, node 3 has a value of 3, and node 4 has a value of 4. So here in this so this is the data of the node. and here this is the next of our node. So the value here is the address of this node. So let's say that the address of this node is 2000. So on our first node the value is 1, but the address is for the second node 2000. And then here our position 2, so the address here is 3000 because that's the address of our node 3, and here 4000. And then here our last node is null, so this is null. So when you delete an element, for example we will delete this third element, third node. So if you will delete this third node, what we will do is to redirect the list. So here, so instead that the node 2 points to this node, so we will change this. So we will change the address of 2 to, we will change the address of 2. So instead of 3000, so we will now put the address of node here, this node 3. So instead of 3000, so we will now update that to 4000, and then that will, so now that it is 4000, so that will point to this node here because this is address 4000. So that's how you will delete a node from linked list, and then we will free this node. So we will call free, and then we will call this node. So that's how you delete, that's the representation of deleting a list or deleting a node from the list. So now let's look at the code. So first we store start to ptr, and then we created a loop, so from 0 to the position, desired position of the user, and then here temp equals ptr. So ptr is the value of start, so ptr we will store it to temp, and then here we increment ptr, so ptr equals ptr next. So this increments the ptr, so that means if you think about it, so ptr is the current position of the loop, and then temp is the previous position of the loop. I mean ptr is the current node, and then temp is the previous node. So now if ptr is equal to null, so if we found a null for the ptr, that so we will print position not found. So why is that? So for example we have only 5 lists and the user entered position 7, so of course the ptr for that will be equal to null, so we will print position not found. So this just for when the user put an invalid position, or you could say here that position is invalid. So after next to that is here, so temp, so if ptr is not equal to null, so here temp next is temp next equals ptr next. So that means that in this representation, this is temp, and this is ptr. So ptr is the current node, so we will delete here. So temp next, so this is the next of temp 4000 equals ptr next. So the next of this ptr is 4000 before we deleted this. So this is 4000. So temp next is equal to ptr next. So that means that the value here, the pointer here, we will store it to here. So that's how we executed the function delete node. So let's go back here. So here and then we print here the deleted element is ptr data. So ptr data, so this is ptr, our current the data that we want to delete. So we will display its data, so we will display 3. So that's how this code works. And then we free the ptr to release the memory of ptr. So now let's go here for the search data. So first is to create one pointer. So we have here ptr and then num and I. So num is for the value you want to search, and then I is for the counter on what position our node. So here we'll ask the value the user want to search, and then we will store it to num. And then if start is equal to null, so we will check if we have a list or not. So else if start data is equal to num, so if the first node, if the data of our first node is equal to the value that we are searching, so we will just say data found at position 0. So start is a global variable, so we can easily access that. And if the number that we are searching is not in the start, so we will execute this code here. So start, we will store it to ptr, and then we will loop ptr. So while ptr next is equal to null, here we will count how many times our loop is executed, so that we will know on what position our data has been found. So if ptr next data is equal to num, so I will just say data found at position I. So I is the counter of our loop, and then ptr next, so this is to increment ptr. So that's it. So that's how you create that's how you search data in linked list and also delete data in linked list. So let's try to run our code. So this is now the final program that we have created. So this is from the previous program and this program. So let's run this code. So when you run this code, so here we have 6 options. So first is create, insert, delete, display, search, and exit. So before that, we will create a list. So enter the data, so let's say 1, 2, create again 3, and then display. So we will display, so to check if list has been created. So now we have a list 1, 2, and 3. So we will start here, delete node. So we will delete 2. So 1 is in position 0, 2 is in position 1, and 3 is in position 2. So let's delete 2 in position 1. So let's choose 3 to delete. So enter the position, so let's say 1. So now the deleted element is 2. So let's display the list if we successfully deleted it. So 4. So here, so from 1 to 3, so we have now 1 and 3 only. So that means that our delete function is successful. Now let's try our search function. So let's choose 5, and then let's enter 3. So let's search 3. So data found at position 1. So correct again, because 1 is in position 0, 3 is in position 1. So that's it. So that's it, guys, for this video. I hope I helped you in some way, and I hope you understand my explanation. So if you like my channel, so please don't forget to subscribe and share this video. So thanks for watching, and keep safe.